coming to see. In continuation for yesterday's class, we try to solve few numericals and addition and subtraction. Suppose here a bar one vector is equals to say some like 2i cap minus j cap plus 4k cap. This is one vector. And d bar we are taking it as like some I cap plus j cap. Today I am changing the numerical plus 2k cap. Okay. Then first simple question. Find the magnitude of a bar minus b bar. Okay. Who is this? Sharmukh. Okay, right. Magnitude of a bar minus b bar. And that of b bar minus a bar. Then how to solve? It is a simple question. So if you check there, here first a bar minus b bar, how much you are going to get in vector subtraction? Directly by seeing the above two values here, I am going to write direct subtraction. A bar minus b bar means 2i minus I. 2i minus I is I. Minus j here by subtracting. Minus, that is minus 2j I am getting there. And this is plus 4 and it becomes minus 2. Plus 4 minus 2 is 4 minus 2, 2. 2k cap. Okay, this is a bar minus b bar. Okay, and simultaneously if I check b bar minus a bar, I won't do again every subtraction here like I minus 2j minus of minus 2 minus of this one. Directly I write b bar minus a bar from my knowledge. It is minus of a bar minus b bar, negative vector of a bar minus b bar. In commutative law, we wrote like this. A bar minus b bar is not equal to b bar minus a bar, but a bar minus b bar is negative of b bar minus a bar. Remember this point now? So using this concept here, what I'm going to write, already I found a bar minus b bar here. So negative of this one. Negative of this one means minus I cap. I will get negative of negative, that is plus 2j cap I will get. And negative of negative, I will get plus 2k cap here. Okay. Then he is asking the magnitude of both. Magnitude of first, if you check there, mod of a bar minus b bar first. That is equals to how much you get there, root over like ax square plus ay square plus az square, that is 1 square plus minus 2 whole square plus minus 2 whole square. This is 4, 4 plus 4, 8, 8 plus 1, 9, root 9 is 3. Okay. And mod of b bar minus a bar, how much you get? Without my help, you say, by taking the magnitude, root over how much, and finally how much you get there. Will anyone say the answer? You said something, Nana. I think you are not audible.
Sir, answer is 3.
Yes,
Yes,
exactly.
3.
Yes. Again, you will get minus 1 whole square means 1 only. 2 whole square is 4. Again, 2 whole square is 4. 4 plus 4, 8 plus 1, again 9. Root 9 is 3. Exactly. Okay. That's the commutative law, what we say. I'm going to prove here. They are equal. Magnitudes are equal. Mod of A bar minus B bar is equal to mod of A bar, B bar minus A bar. But A bar minus B bar is not equal to B bar minus A bar. This is a proof from vectors. Okay, in commutative law. This is one example here for us. And we are going to the second example. Okay, shall I move to next example now?
Yes, sir.
Okay, shall I start? Right. Coming to the second example here. This time, what I'm writing here, A bar is equals to like some I cap plus 2j cap plus 3k cap. And B bar I am writing here is equals to minus I cap plus 4j cap minus 3k cap. Okay. After giving this, what he has given the additional information, if C bar is a third vector, then two A bar minus 3B bar minus C bar equals to 0. He has given this information. Okay. 2A bar multiplied with a scalar number. So it is commutative law. Okay. Sorry, not commutative law, distributive law. And this is 3B bar multiplied with a scalar, again distributive law. Minus C bar equals to 0. Then what he wants to find the magnitude of C bar. Okay, this is the question, Anna. But in this question, you want the magnitude of C bar and A. First, you need who is C bar that we have to write or not. Okay. So if you know the C bar in the vector form like I cap, J cap, K cap in this vector form, then you can easily find out its magnitude. Root over like ax square plus ay square plus az. So first of all, we have to find out C bar. Okay. So from the given information, I can't say C bar is how much. Why? Because he did not mention C bar is how much. Only from the given information, I have to say C bar equals to how much. So first I am going to write the given information, that is 2A bar minus 3B bar minus C bar equals to 0. I am first writing this information. Okay. And the C bar from the above equation means negative C bar taken to the other hand, that becomes plus C bar. So plus C bar is equal to, you are getting how much? 2A bar and then minus 3B bar. Now you check, is it possible to find out C bar or not? Yes, it is possible. Why? Because C bar equals to 2A bar minus 3B bar. In this A bar we know, being this B bar also we know. So both you try to substitute here. That is equals to how much, sir? 2 times 2A bar, directly multiply with 2, Nana. This vector multiply with 2 means 2 times I cap. Multiply with 2, 2 2s are 4 plus 4K cap, sorry, 4J cap. Multiply with 2, 2 3s are, that is 6, 6K cap. This is 2A bar, Nana, minus negative of 3B bar. 3B bar means multiply with 3. Multiply with 3 minus 3 I cap. Next followed by multiply with 3. 3 4s are 12 J cap. And then multiply with 3. 3 3s are 9 minus 9 K cap. This is the vector. So here simple doing the subtraction. First I cap with I cap, that is 2 I cap. I cap, if you see here, minus of minus, that is plus 3 I cap. This is I cap term. Okay. Followed by plus 4 J cap. And here minus of plus minus 12 J cap. You are getting there. Okay. This is not 1.2. This is 12 minus 12. And then followed by plus 6K cap. And here minus of minus, that is plus 9K cap. Okay. Now you can say, well, how much is C bar? That implies, right in here, C bar is equals to 2 I cap plus 3 I cap is how much, Nana? 5 I cap. Here 4 minus 12. 4 minus 12 is minus 8. So plus of minus minus 8J cap. And then followed by how much you check there? Plus, this is
15K cap.
right, very good. 15K cap. Okay. Now finally you found C bar like the vector form, Nana, IJK form. IJK form, after finding out, you know how to find the magnitude. Mod C bar is equals to root over. Okay. Root over here 5 square plus minus 8 square plus 15 square. Okay. So here ax square plus ay square plus az square. How much is this, Nana? Anyone? Try to simplify it quickly.
Root 314.
314. Yeah, exactly. You are right now. Root 314. Nice. This is root of 314. Is there any simplification for this, Nana? Root 314, is it multiple of 4? No. Multiple of 9? No. Only multiple of 2, I think. So we can't simplify. Leave it, Nana. Root of 314. Okay. This is the magnitude. Right? Means on vector subtraction, here we did 2 numericals. Okay. And I think in the previous classes, day before, I think Monday class or Tuesday class, I said about null vector. Anyone remember, Nana, null vector? Null vector means whose magnitude?
Yes, sir.
How much, Nana? Null vector is?
Magnitude is 0.
Magnitude is 0. Sir.
And it does not have a specific direction.
Very good, very good, very good. It does not have any specific direction. Exactly. Magnitude should be 0. That is null vector. Okay. Now what he is saying, look at in the previous question, 2a bar minus 3b bar minus c bar equals to 0 means addition of these three, like a 2a bar plus minus 3b bar plus minus C bar, addition of these three is equals to 0 means the sum is a null vector or not? Okay. Addition resulting 0. It is a null vector. That null vector concept here he is applying like this. This is one particle atom. This is a particle. Okay, placed on a surface whose mass is, say, some 1 kg. Sorry, 1 kg. Okay, this is 1 kg. And he said he is going to apply some forces to move it. If you apply the forces, obviously it tries to move. Okay, how he applied the forces? One is F1, another is F2. Two forces he applied like this, either upwards or downwards, but perpendicular to the first. Okay, these are two forces. This is F1 and this is F2. Okay, two forces perpendicular to each other. Okay, at right angles. Okay, right angle to each other. Okay. Actually, when force is applied, the body should move, Kadanana. Okay, should move with an acceleration A such that F is equals to, I think all of you know one formula in terms of acceleration. Do you know this formula? M into A, F equals to?
Yes, sir.
Good. F equals to MA, where A is acceleration. We know in school, actually, this equation. Force applied, this is F. Okay, and mass is, M is mass, all of it. It is mass. Mass of object. Here, what he is saying in the figure, in the given figure, he is writing what when a third force F3 is applied, the body is at rest. At rest means acceleration how much, Nana? 0 kada. At rest means acceleration is 0 means M into 0 is F equals to 0 kada, Nana? By multiplying with 0.
Yes, sir.
F is 0. F is 0 means resultant force of F1, F2 and F3 is equal to 0. That you have to understand. The body is at rest means in solution, one of the steps we write like this. What? Since the body is at rest, after applying additional force F3 means already F1 and F2 are there. So F1 bar plus F2 bar, F2 bar plus additionally F3 bar. Three forces are there. Sum of the three forces, since the body is at rest, is the resultant force Fri, right? That is equals to 0. Since the body is at rest under the given condition. Okay. So under the given condition, what I am saying, when one of the forces is removed and three forces are there, resultant is a null vector. Kani if what he is doing, F3 is removed, అంటే F3 లేకపోతే is the resultant force 0 నాన్న, అంటే F1 plus F2 is equals to 0. 0 ఎట్ అవుతుంది నాన్న, F1 plus F2 is minus F3 కదా, not equal to 0. Okay, so resultant force is not equals to 0. And second information from the question, F1 and F2, F3 is removed and two forces are there. So we can say one more thing, F1 bar plus F2 bar is equals to, by taking F3 bar to the other hand, we can write minus F3 bar. Okay. So here, if F3 is removed, F1 plus F2, and F1 bar plus F2 bar is not equal to 0. Is not equal to 0. Okay. So some force is there that we have to find out. So in the question, again coming back to the question here, is removed the body. Okay, is accelerated. With some acceleration. Okay, if mod F3 and the magnitude of F3 is suppose 10 newtons, Newton is the unit of force, 10 newtons, then the question is the acceleration of the body is, this is the question, dash meter per second square. This is the unit of acceleration. And we already started the solution, just writing the information. Okay. So once you check the question, if F3 is removed, two forces are acting, F1 and F2. Okay. The resultant, according to the parallelogram law of vectors, resultant will come somewhere here. This is the direction of resultant. Okay. Parallelogram, this is F1 bar plus F2 bar direction. Resultant of those two. And then the body will accelerate in this direction. F1 bar plus F2 bar. In this direction, it will accelerate. Why? Because F3 is not there. Okay. Mari accelerate and take two forces are known. So Fr after removing F3, once you check here, after removing F3 bar, this third vector is removed. Okay, two forces only act on the body. The resultant force is F1 bar plus F2 bar hai kada nana, resultant force is. Okay, F3 is removed. But if you know the resultant force, F equals to, we can use the formula M into A. Okay. And that implies resultant force is F1 bar plus F2 bar is the resultant force, that I have to write it as mass into acceleration bar. Okay. Now look at, he gave F1 bar and F2 bar, both are not given now. Their magnitudes given. Okay. Check there, their magnitudes are not given. So here we don't know F1 bar plus F2 bar to find out the acceleration. So usually we stop the question here. Sir, we don't know F1 bar plus F2 bar, sir. So how to calculate the acceleration, sir? Just we know the mass only, sir. We can substitute in place of M 1 kg. But F1 bar plus F2 bar in the whole question, once again I read, sir, information was not there, sir. Okay, so we don't know the left hand side, so it is impossible to find the acceleration. We try to stop the question. Okay, but once you check back the information what you have got here, okay, F1 bar plus F3, F2 bar is given as minus F3. Okay, so that implies, using the information what I got here, that implies I write F1 bar plus F2 bar, I replace with minus F3 bar is equals to, I write M into acceleration bar. But once again, check the information given here in the question. F3 is equals to, he gave 10 newtons, but its direction not mentioned, like I cap, J cap, K cap not given there. Just F3 is equals to 10 newtons. Just F3 equals to 10 newtons means who is this? The magnitude of F3. Okay. Oh, we know not even F minus F3 bar, that we don't know, but its magnitude we know. That's why I apply mod on both sides. Okay, so come to the question as an answer again. That implies, since I know only the magnitude of F3, I am applying mod of this equation on both sides. Mod of minus F3 is equals to M. Of course, it is a scalar, leave it. Mod of A bar, I write here. Okay. Then here directly I can substitute mod of F3 is mod of negative F3 is mod of F3 only. Okay, so mod of F3 is 10, I substitute. 10 is equals to mass given there, 1 kg here in the diagram. So 1 into mod A bar. That's it. How much you are going to get the magnitude of acceleration, Amma? 10 divided by 1? 10 meter per second. Okay. What he asked, the acceleration of the body is 10 meter per second square. Only this is magnitude, the direction. If they ask, then we have to check. Okay. Right. Now, suppose if they ask the direction, Anna, then look at the question. F1 bar plus F2 bar is in this direction. Whereas F3 is minus F3. Okay. And F3 bar is equals to, we can write here from this pink color box, from this box, Nana. F3 bar is equal to minus of, taking the negative sign to the other hand, minus of F1 bar plus F2 bar. F2 bar means, I think you understood, F3 bar is a negative vector of F1 plus F2. Negative vector means in the same direction or opposite direction, Anna?
Opposite direction.
So exactly in opposite direction, now we have to draw F3. This is the direction of F3. So blue color line is F3 bar. Okay. It is looking like, and suppose it is a coordinate system like x-axis and y-axis. In the coordinate system, we can say that it is in which, looking like in which quadrant, Nana? First or second or third or fourth or looking like?
Second quadrant.
Second quadrant.
Ah, exactly. It is looking like in the second quadrant. Okay. That just we can say. Okay. But the angles here we don't know now. That's why perfect direction, it makes how much angle with x-axis or y-axis we can't say. Yes, we can say it is in opposite direction to F1 and F. Okay. Understood this question, Anna? Do you have any doubt?
No, sir.
Yes. Okay. If you complete copying this question, I can move to next page. Okay, right. Again, we will read the question. This is mere time waste. Mass, I think we took 3 kg kada Nana?
Yes, sir.
This is one string and this is another string I think we took. Sorry, simply this time we draw a short line here like a roof. This is roof and this is wall, what we are taking. Vertical wall. And here, this is the roof. Making, I think I gave 45 degrees here. Okay, and this is given as some 3 kg, I think. And it is here. Roof. Sorry, this is wall. So one we have drawn what, Nana? Weight vertically downwards. This is mg. And we have resolved this force into 2 components, one in this direction, other in the vertical direction after resolving. Like this. And here we took, this is 45 degrees. And I wrote here, this is T cos 45. And this is T sin 45. And this is mg. Okay. So here, m equals to, we took 3 kg and g 10 meter per second square kadanana. So finally, we got mg is equals to 30 newtons by multiplying both those two. Okay. Now I think we are here. T is what, Nana? Restoring force.
Restoring force.
Restoring force. in the string. Why the restoring force is developed on a restoring force? Because of weight. Weight tries to pull it downwards, not to elongate. Some tension is developed in the string. That restoring force is called as tension. Okay, right. This is the restoring force. Oppose the applied force and a weight. Weight tries to pull it down. So to oppose, tension will act. Oppose and in opposite direction, not in the same direction downwards. Like we have to take upwards. Upwards along the string, we have to take in the upward direction like this. Okay. Since it is looking like in the second quadrant, the two components we have drawn here. T cos 45, T sin 45. Okay. Yeah. Now check here. This T cos 45, one of the components of tension developed in the upper string, T cos 45, tries to pull the mass forward. Okay. Now check here, this mass again can't move freely. It is again connected to another string, red color string towards right. So immediately what happens when the mass tries to move towards left, immediately in the string towards right, in the string, some tension will be generated. Okay, both the strings are not same. So that's why I can't write here and there's the same tension. So to distinguish, here I write T1, there I write T2. Okay, that luckily came exactly along x-axis. Exactly along x-axis in the string, no need to resolve. That is already along x-axis. Okay. Now look at the question, what he said. He said the 3 kg mass means the mass is, it can't move. Why? Because the other side connected to wall now. One side connected to roof. It can't move either towards right or towards upwards or downwards, even towards left. Okay. So the mass is, suppose he said, in equilibrium, this word you have to notice. Equilibrium means what, sir? The resultant vector on the body when many vectors are acting is a null vector. Okay. Null vector means resultant of all the vectors, okay, all the vectors is equal to 0. So the mass is in equilibrium. That is, in case of forces, F resultant is equals to 0, null vector. This is equilibrium. Fr bar equals to null vector. So better we write like O bar. O means 0 bar, null vector is in equilibrium. Then find the tensions in the strings. Find the tensions, T1 and T2. This is the question now. Okay. Actually, T1 cos 45, T1 sin 45, they are not the original forces acting, they are components now. Originally, the forces acting are, one is T1 in the string, other is T2 in the string, number 3 is mg. These are the 3 forces acting, T1, T2, mg. So 3 forces are acting in different directions means I have to write according to, coming to the solution, Anna. First, you understood the question? All of you? Shall I start the solution here?
Yes, sir.
Sure? Okay, so I'm going to the solution now. Okay, solution here, 3 forces are acting, T1, T2 and mg. So since it is in equilibrium, resultant force is 0. I have to write resultant force of 3 vectors, that is T1 bar plus T2 bar second vector plus third vector is mg. M G, acceleration due to gravity is acceleration. In the previous page, I said acceleration is a vector. So mg bar is equal to 0, sum of. It is a null vector. So 0 bar I write. Okay. Now I write in coordinate system, Nana, like I cap, J cap, and K cap. Okay. So here I am going to write T1 is in second quadrant. Second quadrant, already I resolved the two components. One component came along negative x-axis. So T1 bar, I am writing like T1 cos 45 negative x-axis minus I cap. Okay. And its another component is T1 sine 45. This is T1 sine 45. That is along positive y-axis. Positive y-axis means plus j cap. Here and right. So T1 part I wrote, Nana, with the two components, T1 cos 45, T1 sin 45. Next followed by T2. T2 also I know, plus T2. Okay, that is perfectly along positive x-axis. So plus I cap, this is over. Next mg. Now you say mg, Nana. Mg is in what direction?
Downward direction.
Downward means coordinate system, you say. Plus
Minus J cap.
Minus J cap.
very good. Minus j. That is correct. Yes. Negative y-axis. Correct, Nana. Lahari. But it is minus j cap, negative y-axis means. So minus j cap. So all together equals to 0. Okay. Again 0 bar also the null vector. Shall I write like this? Okay. How? Like a 0 I cap. Since it is 0, everything is 0. So 0 I cap plus 0 j cap. Nothing but 0 only. Okay. So once you check here what you are getting I cap components and j cap components, Nana. Here T1 cos 45, all of you know, 1 by root 2. So T1 by root 2 times minus I cap. This is 1 I cap. And another I cap is plus T2. So I am taking I cap common here. So plus T2 all together I am taking here into I cap. Okay. T1 plus minus T1 by root 2 plus T2. I cap components over now. Next J cap components. Plus here J cap I am finding out T1 sine 45, that is also 1 by root 2. Okay. And here this is minus j cap. So minus mg into j cap. Okay. This is left hand side, that is equals to 0 I cap plus 0 j cap. Okay. Suppose if you get a vector x I cap plus y j cap is equals to 2 I cap plus 3 j cap. What are the values of x and y? And what do you say, Nana? What are the values of x and y if this vector is equals to 2 I cap plus 3 j cap? X is how much? Y is how much?
2 and 3.
Ah, very good. And I cap you are equated to I cap, that is x is equals to 2. J cap you are equating with j cap, y equals to 3. In the same way here you have to say. That is minus T1 by root 2 plus T2 into I cap. So their I cap component is 0. So this is equals to 0. And another one. T1 by root 2 minus mg. This is j cap component now. J cap component is also 0 there. That is equals to 0 on the right hand side. Okay. So simple. First you go with the second equation, Nana, you will get the answer. Why? Because I know mg. So from this equation, what I write, that implies T1 by root 2 equals to mg. Mg is given as how much, Nana, here? 30. So this is equals to 30. Yes, 30 root 2. T1 equals to 30. That is equals to 30. That implies T1 is equals to, by taking the cross multiplication here, this is equals to, I write 30 root 2 newtons, since it is a force, newtons. Kadanana? Now you go to the first question, means first equation, this equation. T1, answer for one of the questions is what? Find the tensions. Okay. So T1 part is over. So to find out T2, I'm going to this equation, Nana. From this equation, what I'm going to write, T2, I keep it on the left hand side, is equals to, take minus T1 by root 2 to the other hand, that becomes plus T1 by root 2. Okay. So happily you can say what? T2 is equals to T1 by root 2. Right, very good. This is Vagam, correct? 30 root 2 by root 2. Okay, root 2 cancel, that is equals to 30 newtons. Okay, hence we got the answer. 30 root 2 by root 2, yes, 30 root 2 by root 2 is root 2 cancel, that is equals to 30. Okay, now you understood the question on equilibrium model? Yes. Right, good. So if you say yes, copy it, sir, then I will move to next page. Now, suppose the question. I think you can solve this question very easily. Sum of two vectors means P bar plus Q bar. Generally, we represented with the letter R bar, Kadanana. So this is R bar, as usual, he said. And the second one, what? Subtraction of two vectors, P bar minus Q bar, equals to generally what we take? S bar. Okay. So here addition of two vectors is R bar. Addition of the same two vectors, Nana, keep in mind, same two, not other two vectors. PQ, here also PQ, same two vectors. Subtraction is S bar. And like one diagonal is R bar, another diagonal is S bar in parallelogram of vectors. Okay. Then the question is, here, find the value of what he is asking, R square plus S square. Keep in mind, not R bar square plus S bar square. R square plus S square means mod R square plus mod S square. Okay, magnitude of R square plus magnitude of S square. And just if you remember the formula what I gave for magnitude of addition of vectors, magnitude of subtraction of two vectors, it is very easy to say the answer. Okay, remember the two formula, magnitude of R bar and magnitude of S bar. I think according to parallelogram law, you remember this is P square plus Q square plus 2PQ cos theta. Between the same two vectors, mod S bar is equals to subtraction. This one also you remember, I think, I believe, I trust, P square plus Q square minus 2PQ cos theta. Okay. Squaring means after squaring both, here square root will be gone, here square root also will be gone. And R square plus S square, I think almost you found the answer. Thus it is equal to, by squaring this one directly without square root, we write P square plus Q square plus 2PQ Yes, I identified. Yeah, 2 times. Very good. Who is this? Diagram. Diagram, super. 2pq cos theta. Okay. Plus s square. S square is squaring of this one. Square it will cut. So p square plus q square minus 2pq cos theta. So by adding these two, minus 2pq cos theta plus 2pq cos theta will get cancelled now. Positive and negative will cancel. So finally, how much you are getting there? This is equals to p square plus p square, 2 times 2p square. Q square plus q square, 2 times 2q square. So p square plus q square times 2, common taken 2. So answer is r square plus s square is 2 times of p square plus q square. This is not mod number. This is bracket. P square plus q square of 2. So is it clear? ఈ క్వశ్చన్ ఏమైనా డౌట్ ఉందా?
Yes, sir.
Yes. Yeah, clear. So no doubt. Copy. Copying అయిపోతే we will go to next question. Will we start?
Yes, sir.
Yes, sir.
My next question వెళ్దాం. Right? This is the last question. Right? Then I think you can solve. For your sake, I am giving one easy question. This is the question I am giving here. Equilibrium means, remember Rana? Equilibrium means sum of all the forces is equals to 0. Remember this concept? Related to equilibrium, again I am giving one question here. There are 3 forces that are F1 bar, F2 bar and F3 bar. 3 forces are given here. And F3 bar. Okay, once you check what are the values given there. This is F1 bar, sum A times I minus J plus K. Okay, this is. And F2, what he has given there, once you check, 2I cap minus 3J cap plus 4T cap. Oh, F2 is completely known. Nothing unknown there. But look at in F1, A is unknown. Okay. Oh, I think before completing the question, we understood he is going to ask to find the value of A. Okay. Once we wait, here what he has given, we see the full information what he has given there. 8I cap and this is minus 7J cap plus 6K cap. Okay, these are the 3 vectors given for us. Okay, next we are waiting. The 3 forces keep a particle and a mass in equilibrium. Whatever we are expecting, that information we got in equilibrium. That's it. We are waiting for this word. Okay, in equilibrium. In equilibrium. I say what? Find what we are expecting. The same thing he is asking. Find A. A equals to how much? Mari, I think you have the idea how to solve when you come to solution. Okay. మరి equilibrium అంటే sum of all the vectors equals to 0 కదా నాన్న. Sum of all vectors means f1 bar plus f2 bar f2 bar plus f3 bar f3 bar is equals to 0. Okay, sum of all that. So here f1 is unknown, Nana. That's why you keep f1 on the left hand side and bring the remaining two on to the other hand. And like a negative minus of, that is again bracket, Nana, not mod. So better I draw like this. F2 bar, I put the bracket, minus of f2 plus f3. Okay, this is f3. Oh, I think someone got the answer. Again diagram, minus 10, na? Super. Diagram super, na? F2 plus F3. Okay. So F1 ante just multiply, nana, here. A I cap distributive law. A I cap minus A J cap plus A K cap. Okay, I think even you also got the answer, I believe. Why? Because diagram got the answer. F2 bar plus F3 bar means 8 plus 2, 10 I cap. Luckily, we wrote one below the other there. And minus 3 minus 7. Minus 3 minus 7 is minus 10 J cap. And here 6 plus 4, 10 K cap. Okay. After multiplying with the negative sign, you are getting this is minus 10 I cap, minus of minus, plus 10 J cap, and minus of plus minus 10 K cap is equals to A cap, A J cap, A K cap, Nana. And Nana, here just to I think this is easy to understand. Without multiplying with the A, just I keep A outside only. I minus J plus K times A. Now you can easily understand. Okay. Now you take minus 10 common. This is better. Not 10, Nana. That's what I'm saying. Don't get confused. That is minus 10. Check there. To get I minus J plus K, I am taking from all the three minus 10 common. And in the above step only better, you take 10 common. That will be more easier for you. And here already negative sign there outside, 10 taken out, 10, 10, 10 common. Then check here, you are getting I cap minus J cap plus K cap. Same vector ij plus k, I minus j plus k, I minus j plus k. So multiple of a, multiple of minus 10. And then what is the value of a? Is it plus 10 or minus 10? Minus 10 karna na? Right. A is equals to minus 10. Yeah, good. Typing mistake. Huh? Very good, Nana. Larry. So finally you got the answer A equals to minus 10. Okay. Good, good. This is the problem here. Few problems we solved related to addition and subtraction, Nana. Any doubt in the class today? Do you have any doubts, Nana? Followed all the questions? Able to solve?
Yes, sir.
If you say confidently, I will stop the class. Okay.